The James Webb Space Telescope is the successor to the Hubble. Well, James Webb is a telescope that's going to have 7 times the collecting area of Hubble. You could fit 7 Hubble mirrors in our optics. It's going to operate 1 million miles away from Earth, where Hubble is only 300 miles away from Earth. We're going to look 13.5 billion years back in time. It also is going to operate colder at minus 388 degrees Fahrenheit. So this is what's called our third scale sunshield model. This is never going to fly in space. And the reason we created this is because the full scale model doesn't fit in a thermal vacuum chamber, meaning a place where we can pull the vacuum of space and simulate the thermal environment of space. So it's what we call a surrogate method of proving something. One of the things you can notice, it's not one piece of material. There's seams in there. You can see rectangular sections of this. So the way this sunshield works is it's literally a big umbrella. It's going to keep the optics at minus 388 degrees Fahrenheit. The sunny side is going to be plus 188, and the cold side is going to be minus 388, almost 600 degrees. We do that by creating a 5-layer Kapton sunshield and umbrella, but we can't do that out of one piece of material. We build it by a small sets of pieces of material, and we actually thermally seam those together. They have what's called spot bombs. And we create a 3-dimensional shape, almost like creating an article of clothing. And then in the very center, that's where the optics would be mounted. That black ring that you see there, those rings and hoops in the middle, in flight, that's where the optics go. Basically, they stand out and they would be looking, in this case, towards the ground, and they would be looking at light, but they would never see the light from the sun behind it. This big, basically, umbrella will be blocking that light. Optics in the middle, big umbrellas around it, 600-degree Fahrenheit of differential from how it blocks the sun to what the mirrors see. The magic about the Webb telescope, though, is there's no rocket that can lift something in a configuration that's 80 feet long by 40 feet wide by 40 feet high. So we start in a very compact form, and then as we're flying on orbit, we're actually deploy over the first 2 weeks as we transition. But the telescope has mirrors that collect light, instruments that do science. They're made cold by having a big umbrella that effectively shades them from the sunlight, and they get operated on orbit by a bus. And a bus is a simple name because literally it drives us around. It has our fuel tanks and it lets us communicate with Earth. Us as a company, Northop Grumman, we build this for NASA as a means of being a part of a bigger thing, right? And that's pretty much everything we do. All of the data from Webb eventually becomes public domain knowledge. People who are following on after their doctorate degrees into the fields of astrophysics and astronomy will be using the Webb telescope. We know this is an inspiration for kids to want to be engineers. So we do missions like this, not just for the end state of the data they're fine, but they're inspirational to say, let's do something beyond this. And that's what the next generation, hopefully, that's what the kids in the schools that I go and talk to are going to want to do. They're going to want to build the next best, telescope.